Welcome everyone to another presentation up to the time. Now, if you're first joining us here, let me explain to you how things are going to go for this presentation. On the left-hand side, you're going to be seeing the work screen, which is the AutoCAD screen, and on the right-hand side is the information screen, which is the question on this side. So without any further ado, this is a CXC question. So I'm not going to spend lots of time on this question. I'm going to try to do this question quickly as if I were under examination conditions. So let's get straight into it. Question 3 reads, Figure 2 above shows the details of an ellipse. Let me enlarge this. Figure 2 above shows the details of an ellipse. Construct the ellipse using any suitable method. From a point on the outside of the ellipse, construct a tangent to the circumference of the ellipse, showing clearly the method used for obtaining the point of contact. So this question shows us that above is an ellipse. They say A to B is 100 millimeters, and that's the major axis. C to D is 60 millimeters, and that's the minor axis. And then there's some point P that's located outside the ellipse. The idea of this is that we are going to be connecting this point P to the ellipse and creating a tangent. So in a nutshell, let me just explain this with one line quickly. We're going to be connecting a line here to somewhere onto the circle, onto the ellipse and creating a tangent and stuff like that. So let us get into this. Let's start drawing. Alpha line, as you go over to AutoCAD, alpha line. And the first thing I'm going to draw is I'm going to draw my axis. That's a good enough axis there. So let's start off with A to B, which is our major axis of 100 millimeters. So that means if we create a circle, that means the radius of the circle is supposed to be 50 millimeter diameter. C to D is 60 millimeters the diameter. So that means the radius is 30 millimeters. So let's go see the circle, open up at this point here. I'm going to type in 30. So I have both my major axis and my minor axis inserted to create the two circles. These two circles come together and they form what is known as a concentric circle. These are concentric circles. Concentric circles just mean they all share the same axis point right here in the middle. Now, let's put labels next to these points. So I'm going to come in here, A here, B here, D here, C here. I'm going to place these into the text layer because I'm drawing everything on the construction layer. Now that's into the text layer. Super. I'm going to place these lines here into hidden. I'll put them in center line. Yeah. Makes more sense. I'll just bring it. Perfect. Now, we have our two circles in that we are going to start this process. The first step we need to do is to divide these circles into 12 equal parts. So seeing these circles both share the same axis point, if I divide the outer one, I can use the divisions on the outer one to influence the division, to influence the inner circle. So let me explain what I mean. So I'm going to divide the outer circle only but by dividing the outer circle, I'm also going to get the divisions on the inner circle. Let's go. D is the command to divide. Select the object and type 12. Because 12 is the number of divisions that I want. Let us connect these. This is the first division here, and we connect it down here. And each line must pass through the axis point of on in. So I have my divisions. Now what I'm going to do is I'm just going to place my numbers here. So those at home will be able to understand what I've just done here. Be 1, this would be 2, this would be 3, this would be 4, 5, 6, 7, 8, 9, 11, and back at 12. Essentially what I did is I created a clock face. So you have 12 at the top, 6 at the bottom, and this whole thing goes right the way around. So what am I doing now? I'm just renumbering so everything is in the proper, everything is labeled properly. All this acts as part of the construction phase in the drawing. What I'm going to do, I'm going to place my text into my text layer. So I've also placed the text into the text layer along with the points. Now, so exactly what I said. The outer circle is divided into 12, and similarly is the inner circle divided into 12 also. And this was possible because they all share the same axis point here in the middle. Now, what is the next step? Now, from the outer circle, I'm going to project lines vertically. For those who might not know what vertically means, lines going from a direction up to down or north to south. Those are vertical lines. So let's go. I'm going to switch the layers now so as not to confuse anyone. I'm going to use the dimension layer for this next process. So alpha line, and let's start at 1. So 1 goes all the way down to 5. Right? And I'm going to copy 1 that goes to 5, and I'm going to connect 2, and 2 goes to 4. 11 goes to 7 down here, and 10 is connected to 8. Right? So everything 1, the line from 1 goes down to 5, vertical line. 2 goes down to 4. 11 goes down to 7. 10 goes down to 8. Now, at this stage, I'm going to trim these vertical lines because we don't want any lines extending past where we're supposed to be. Now, so that means if we have connected 1 to 5, 2 to 4, 11 to 7, 10 to 8, and those are all done vertically, what's going to happen now to the inner circle? Now, we go back to those same numbers, and those numbers that I'm going to start off here, let's go to the one that is on the inside of the circle. So this is what I mean, but this is 0.1 on the outside, and then there's also a 0.1 on the inside. And that means what I can do then is I can place these points also on the inside of the circle so that everyone can see that I'm also labeling the inside of the circle. Now, why am I doing this? You don't have to do this. if you understand what's the next step. I'm just doing this so as people watching would be able to further understand as I explain this. So when I said point 8, I can reference point 8 either on the outside or point 8 on the inside of the circle. So that means that there are 2 point 8s. That is the outer point 8 and then there's the inner point 8. Just like there would be 2 point 11s outside or point 11 on the inside. So this should make things easier. Now, I'm at point 11, I'm at point 1 on the inner circle. And point 1 is going to go to point 11 on the inner circle. Because the way I'm going to treat this inner circle, all the lines I'm projecting from this inner circle are going to go in a horizontal direction. For those of you who don't know what the word horizontal means left to right, or better known as from west to east. So let's proceed. 1 connects to 11. We're going to check that. We're going to project that past the inner circle. And I'm going to grab that line and I'm going to copy it. And I'm going to snap it in at 2. So 2 would connect to 10. I just need to extend that. And 4 would connect to 8. And 5 would connect to 7. So those are the lines that have just been added. Just extended. All right. So what we have here is a series of bunch of lines. But all of these were set up so that we can find points. Points where 2 numbers intersect. So this makes it very interesting what I've done. I have 1 on the outer circle and I have 1 on the inner circle. So let's see how these 2 ones come together and create a point 1. Right? So 1 on the outer circle, the line goes vertically. 1 on the inner circle, the line goes horizontally. These 2 lines connect. There's an intersection here. So what I'm going to do is trim this intersection. Yeah. And then I'm going to trim the intersection at 2 as well. Now there isn't any intersection at 3 because it will be impossible for these 2 lines at 3 to intersect and make a point based on how they're located on this circle. So points 3, 9, 12, and 6 do not carry intersections. So we can proceed, we can skip that and move on to point 4. That's the intersection there at this 90 degree. 5, that is the intersection. Point 7, that is the intersection. Point 8, the intersection. And again, if you all are not seeing these intersections, I will come back and I will place some points there. Now, let's clean up what is needed before we proceed. Clean up. Now, I'm going to go over to my outline layer and let us put some points at these intersections now. POI brings up the point menu, enter, and let's go. So this is my first point, at point 1 there, where the 2 point 1s come together, forming a 90 degree. Point 2 there, point 4, point 5, we skip 6, like I said, we go to 7, we go to 8, we skip 9, we go to 10, we go to 11, and that's it. So I have all my points in now. The next thing that I need to do is create my curve line. For that, I'm going to use the command SPL. SPL, it brings up the spline. That's it there, enter, and let's proceed. Now, let's start off this ellipse. This ellipse would start off at the point 12 on the inside of the circle. So point 12 on the inner circle. And then we move to the intersection of point 1. Then we move to the intersection of point 2. Then we go to 3 on the outer circle, the section of 4, section of 5, and then we go to 6 on the inner circle. We move now to the intersection at 7, we move to the intersection at 8, we go to 9 on the outer circle, intersection at 10, intersection at 11, and then we return to 12. And that is finished. You hit enter, and that is your ellipse. Now, that is our ellipse. Let us move on to the second part of the question. We are going to be placing point P, which is right here, some distance of 30 millimeters to the right and 6 millimeters down. Once we've located P, we connect P to our ellipse. So the first thing I'm going to do is locate P. So I'm going to come over to this side and I'm going to draw a line up like that. And then I'm going to offset it 30 there. And then I'm going to offset this line 6 down. These two intersect. That is where my point P is, right here. I have located point P. I can just put a NT for intersects. And I'll call that point P. Right? I'll place the point P into the text layer. All right. Now, that looks good. Looks good. That looks good. What's the next step now? The next step is to connect P to this curve. That's going to be easy. But before we do that, we need now to find out, we need to set up this tangent. And how we're going to do that? We first need to create the F1 point and the F2 point. How do we go about finding these 2 points? I think I'm going to come over here and explain this quickly. Distance that's taken from here to here, right, is our F point distance. So the distance from A to B, which is going to be about 50. We are going to come at this point here, up the compass, create an arc here, same compass, and similar arc on that side, and that would be our F2, that would be our F. Then, what we need to do is from here, point P, we need to connect and let P touch, and that we probably touching somewhere here. So then, what happens is that we are going to create a line. Let me use a different color rather than yellow. We're going to create from here, connect it. Then once we have done that, we need to create our angle arc, which is in here to there. And then we need to find half of that. Okay? That there is called the normal. We have the normal, we have the tangent. So this here will be our tangent line, and then this here will be our normal. Now, let me just proceed with this process now that I've explained it. What I'm going to do is I'm going to turn off my dimension layer so as not to get a lot of the confusion. going to measure the distance, the IM, from here to this distance. So I'm going to come at this point and open up a circle of 50. What does this mean? Actually, I'm going to work in a different layer. I'm going to work in my actual layer so that you won't have too many yellow circles onto the screen. So I've opened here and I've created a circle of 50. Why did I use 50? Because my A to B, which is my major axis, the radius is 50. So we use the radius of the major axis. What I'm interested in is these points where they cut. Yeah. So I'm going to place a point. Okay. Call that MQ, and that will be my F1 and O. Right. So move this. So these are in. Now we need a point on this curve. So I'm going to draw a line. Okay, found the tangent point, and the idea is I need to prove it. So my tangent point is right here. I'm going to put a point right there. Right? Now, what do we do with that information? I'm going to connect F1 to this new point and F2 to that same point. L, the line, and connect that there, and connect. So I've placed these points. F1 connects to. Now let's create the normal. First C for circle, and then we're going to put in an arc in here, and then trim it. The reason is because we only need this portion. That's all we need. We just put in an arc. You can even measure this angle if you wanted to. Just wait a minute. We can measure this angle if we want to, and it's 86 degrees. Now, we need to find half of 86 degrees. How are we going to do that? Hit L line and we just hover over the midpoint or where we think the midpoint is on the angle, and it should appear. Okay? That is it there. And that connects. And then we can extend that. So this is our halfway point, and that also is directly perpendicular to the tangent line. So I'm going to extend this line outward, right? So that we can all look at it. So this is the normal, and then this is the tangent. So these all into my outline layer. And I'm going to repeat all this tangent. Or to rotate. Place the word tangent there. Now we need to place the word normal here. Properly, and then rotate it. Normal. Rotate this now So I have the tangent and I have the normal inserted. Placing these into my text layer, and I think I am finished. I've answered the question. I've constructed the, so let's recap before we get out of here. So this is a short presentation. I have answered the question. The question asks, construct the ellipse using any suitable method. With a minor axis of 60 millimeter and a major axis of 100 millimeter. I've done that. This is what it looks like. And they also ask from a point P outside of the ellipse, construct a tangent to the circumference of the ellipse, showing clearly the method used for obtaining the point of contact. So here is the method that they use for obtaining the point of contact. The line is called the tangent. The perpendicular line to the tangent is called the normal. Folks, this is just the end of another presentation. This was a CXC question. This question is deals with constructing an ellipse and then from the ellipse creating a tangent to the ellipse. I hope everyone was able to learn something from this exercise. I would encourage you to please slow down this video, rewind this video, and take it in small chunks. Also, practice makes you perfect and it sharpens you all the time. Lastly, please like and share this content. I am out. Thank you.